Today we are discussing friction. First thing I want to mention is that friction is a force. Remember we said forces or pushes or pulls. And so when you encounter friction, it is usually between the two different surfaces. When you rub your hands together, you feel a little bit of friction as they push. You feel the resistance as they move. If you have an object and you push it and it comes to a stop, it comes to a stop because friction always pushes backwards in the opposite direction of motion. So if I'm pushing it this way, friction's pushing it backwards. If I push it this way, friction is pushing it forward. It always pushes in the opposite direction the object's moving. So friction always acts to either slow the object down and bring it to a stop, or if it's already stopped, it tries to resist the object from moving altogether. Now there are two types of friction. There's static friction and there's kinetic friction. Static friction is when the object is not sliding. So right now the object is not sliding. If I give it a little bit of a push, it doesn't move, and the reason it's not moving is because there is some static friction holding it still. But if I push a little bit harder, if I push more than the static friction can push back with, then it starts sliding, and once it starts sliding, we call the amount of friction pushing back when it slides kinetic friction. So again, static friction is between surfaces that do not slide, and kinetic friction is between surfaces that are sliding. Now the reason why we distinguish between those is because kinetic friction is usually a little bit weaker than static friction. So when an object is not moving, it tends to have more friction holding it in place, but if you can overcome that friction and it starts sliding, the amount of friction will actually become less. And so we have a little video demonstrating that here that you can watch right now. So what we want to discuss right here is the difference between kinetic and static friction. Remember that static friction is the friction that holds an object in place when it's not moving, when it's not sliding. And kinetic friction is the type of friction that an object experiences when it is sliding across another surface. So for example, right here, there may not be a whole lot of friction at the moment that you see, but if I push it, I give it a little bit of a push and it doesn't move, even though I'm putting a force on it. The reason it's not moving is because when I push this way, there's friction between the bottom of the block and the table, and it is pushing back in the other direction, but there's only so much static friction to hold it in place. Once you push harder than that static friction, it can start to move. So we're going to go ahead and measure those static friction, and once it starts sliding, we're going to measure the kinetic friction, otherwise known as sliding friction. So we have a force scale. The force scale tells you how much force you're pulling with. So if you take a close look at the numbers, we have 0, 1, 2, 3, 4, 5 newtons. So this can read up to 5 newtons of force. And so as I start pulling, if I angle this right, you should be able to tell when it's moving. And I pull with 1 newton, 2 newtons, up. And it hit 2 newtons of static friction, and now that it's sliding, we take a close look and we can see it's only reading about 1 newton for the kinetic friction. So the kinetic friction does usually end up being less than the static friction that it has when it's sitting in place. Now there are a few different things that affect the amount of friction. Those two things that affect friction are the normal force and the coefficient of friction, so we need to make sure that we know what we're talking about. Remember, if you're having trouble seeing this, there is a picture of this, a copy of this note set directly in today's assignment. And so normal force, well, basically it's very, very closely related to the weight. Normal force is when you push on something, it pushes back with a normal force. So if I set this object down, let's say it weighs 2 ounces. That means it's pushing down on the table with 2 ounces of force. Well, the reason it's not falling is because the table is pushing back up with the same amount of force. So the weight pushing down equals the force pushing up. So therefore the weight is equal to that normal force, the force pushing back. The only time where this isn't really going to be true is if you have something at an angle. If you have something at an angle, some of the weight's pushing down, but not all of it's being supported, and that's why objects tend to slide down. We are not going to discuss that, so I'm not going to really go any further. For the examples that we're dealing with, the weight of the object will be equal to the normal force. So in the drawing, we have the weight pushing down, the normal force pushing back up, and those are going to be equal amounts. Just as a friendly reminder, that the force of the object's weight, you can calculate by taking the mass times the acceleration of gravity. So if we give you the mass in kilograms, you would multiply that times 9.8 meters per second every second, and that would give you the weight of the object. So we're going to go ahead and take a quick look at how the normal force, how hard the objects are being squeezed together, how that affects the amount of friction. So now we're talking about the normal force and the effect that it has on friction. When we just have the block sitting by itself, the amount of friction it encounters in order to get it to move, if we take a look, it's about 2 newtons before a force that's required in order to move it. But now we put more weight on the object. So it's being pushed harder against the table, and the table's pushing back up harder. They're being squeezed together with more force. This weighs more. So the normal force is going to be equal to the weight of the object. So now that it weighs more, you encounter more normal force, and if you encounter more normal force, now when we try to move it, how much friction do you have to overcome in order to get it to move? 1, 2, 3, 4, 5, about 5 newtons before it starts moving. So increasing the weight of the object increases the normal force, how tightly the objects are squeezed together, and that increases the amount of friction you run into. The next thing we need to talk about is the coefficient of friction. And the coefficient of friction is basically, it's going to come to you as a decimal, and it's essentially the percentage of the normal force, the weight of the object, that acts as friction when the objects are trying to move. Now, coefficient of friction, the symbol for that is this Greek letter mu, but long and short of it, if you want to just draw a cursive U, we're going to be fine with that. And what determines the coefficient of friction is the types of surfaces that are rubbing against each other. So as an example, if you have rubber tires on pavement, you've got a lot of friction. There's a large coefficient of friction. But if you have those same rubber tires, instead of being on concrete pavement, if they're on ice, then the coefficient of friction goes down and you encounter less total force of friction. We usually express the coefficient of friction as a percentage or a decimal. If these two numbers are equivalent, 89%, if you were to write that as a decimal, would be 0.89. Usually you will encounter the coefficient of friction given as this decimal, but you can always multiply by 100 in order to think about what percentage that would be. Here we have some examples of coefficients of friction. Again, if you have trouble reading this, these notes are online on this assignment. And these are just different substances that are pushing on each other. So we have steel on steel. Down here, rubber on wet concrete that has a coefficient of friction of about 0.3. But if we are sliding, we have kinetic friction, it drops down. Remember, kinetic friction is a little bit weaker, so the coefficient of friction drops down to about 0.25. So those would be equivalent. 0.3, if you want to convert that to a percentage, just to get an idea of what you're talking about, you would multiply the decimal times 100 to get the percentage. So a coefficient of friction of 0.3 would be the same as 30%. And so in this example, if you have rubber tires on wet concrete and they have a coefficient of friction of 0.3, 30%, that means that about 30% of the normal force, the weight of that car, is going to be experienced as friction. So if you want to be able to move forward, the car can only put about 30% of its weight to push back on the road so the road can push it forward before things start sliding and you start skidding. So again, think about the coefficient of friction numbers as percentages. Just multiply by 100 and you have your percentage. We're going to go ahead and take a look at how the coefficient of friction can be determined by different types of surfaces that are in contact. In this example, we're going to talk about the effects of the coefficient of static friction. Remember, that is determined by the two types of surfaces that are rubbing on each other. So in this first part, we've got the wood block on the wood table, and as we've seen before, it takes about 2 newtons of pulling force to overcome the friction. So you have to overcome about 2 newtons of friction. So we pull it, and right around 2 newtons it starts moving. Now, we want to change the type of surface, so what we have is a piece of sandpaper. Now I've taped it down on one side so the sandpaper doesn't move, but now we are going to set the wooden block on top of the sandpaper. We're going to see if it takes any more force to get going. If it takes more force to get going because of the rougher surface, that means you encountered more friction in order to get it moving. So now we go ahead and take a look. How much force does it take to get it moving? How much friction do we have to overcome? 1, 2, 3, a little over 3 newtons that time compared to the 2 newtons before. So again, by changing the types of surfaces that are involved, you change the amount of friction you're going to have. We can record that number as the coefficient of friction. So as you just saw in the video, you have different types of surfaces in contact, and as you have different types of surfaces in contact, you get different coefficients of friction, which affects the amount of friction pushing backwards on the object as it tries to move. If we take a look at the formulas that you're going to be using to solve some of these problems, the basic formula for friction is the force of friction is equal to the coefficient of friction times the normal force, which remember is the same as the weight. If you need a little bit of a pointer here, we have just a friendly little reminder here. Normal force is Fn, friction force is Ff, and the coefficient of friction is that cursive looking U. The units for friction and for force of friction and for the normal force, those are both forces, so they're measured in newtons. Coefficient is a percentage. It has no units. It's just a number that you multiply by. So if you take this basic formula, when you rearrange it, you can rearrange it these 3 ways. You should be by now familiar with the formula triangle. We can put that in a formula triangle to help you rearrange it without making mistakes. So if I want to solve for the force of friction, cover that up, and these 2 numbers are next to each other. So therefore, if they're next to each other, you multiply. If I wanted to find the coefficient of friction, I would cover that up. And now what's left, you have the force of friction over the normal force. So since one's on top of the other, you divide. So that would be force of friction divided by the normal force. And then finally, if I want to solve for the normal force, I cover that up. And you see how it's the force of friction over the coefficient. So you have the normal force equals frictional force over the coefficient of friction. Finally, what we have are a few example problems showing you just a few helpful pointers about how you're going to work these problems. So in this one, we have a 4,000 Newton car. That's the weight of the car. And it's driving on wet pavement. So the coefficient of friction, we take a look at our old chart that you'd seen before. The coefficient of friction between rubber tires and the wet road is 0.3. So that's basically saying 30% of the car's weight is going to become friction. How much friction force is there between the tire road and the tires? So if we were to go ahead and draw a quick sketch, the car weighs 4,000 newtons. So the force of its weight is 4,000 newtons. And if it weighs 4,000 newtons, that means in order to not fall, the road has to push up with a normal force. So the normal force is going to be the exact same amount, 4,000 newtons. So this is just to remind you that in all our problems, the weight of the object is going to be the normal force. Now the coefficient of friction between the road and the tires is going to be 0.3 or 30%. And what is it asking us to find? It wants to find the amount of friction force. So we are looking for how much friction is going to be pushing back on the car. The force of friction equals question mark. So there's our givens. Our givens are the normal force of 4,000 newtons. The coefficient of friction is 0.3, and we are looking for the force of friction. So if we remind ourselves that we've got the formula triangle, force of friction, normal force, coefficient of friction. Looking for the force of friction, cover it up. These are next to each other. What's left? So that means we multiply. So our formula will be the force of friction equals the normal force times the coefficient. So basically, we are taking the normal force, the weight of the car, which is 4,000 newtons, multiply that by the coefficient of friction, which is 0.3. So 30% of the object's weight turns into friction, and if you multiply those numbers together, what you should end up with, you can try it yourself, but you should get 12,000. Now what are the units going to be? Well, that's Newton times no other unit, so it's just going to go ahead and stay newtons, and there's your answer. For the second one, we've got a metal box. It's being slid across a wooden floor. The box weighs 250 newtons and encounters 100 newtons of friction as it slides. We want to find out what is the coefficient of friction between the metal box and the wooden floor. So you've got your floor, you've got the box. If the box has a weight of 250 newtons, then that means there is a normal force pushing up on the box of 250 newtons. Now, let's assume that we're moving it this way. If we're moving it this way, friction is going to push in the opposite direction. So friction is pushing back. The force of friction, it says, is 100 newtons of friction. And we want to find the coefficient of friction. We want to find what is mu. So you can just go ahead, if you make a drawing, you can leave it like that. I'll go ahead and label everything right here just to be complete. Frictional force is 100 newtons. The normal force is 250 newtons. We're looking for the coefficient of friction. So again, looking back up here, if we want to find the coefficient of friction, cover that up, and you see force of friction is on top, normal force is on bottom, so we divide those since it's one on top of the other. Slide this up for you. So the coefficient of friction is the force of friction divided by the normal force. We go ahead and plug those numbers in. The force of friction we had said was 100 newtons. The normal force, the weight of the object, was 250, so we plug that in on bottom. And when you divide those numbers, you can go ahead and calculate it out yourself. You can pause the video. But when you get your answer, you should come out with 0.4. And then as far as the units go, we have newtons on top, newtons on bottom. When you take anything divided by itself, they cancel. So there end up being no units. As we said before, the coefficient of friction is just a multiplier. You could express that as a percentage. 0.4 would be the same as 40%, basically saying that the box is going to encounter 40% of its weight as friction because of the two types of materials that are in contact, wood and metal. If it was metal on metal, it would probably encounter even more friction. The coefficient would be larger, meaning a bigger percentage of its weight would turn into friction.